Okay, the final prelim topic that I'm going to give us is about expanding expressions, which is really the kind of the opposite of factoring in a sense, although I made it a little more complicated than that, but okay. So when we're expanding expressions, if you are really familiar with sum of squares and difference of squares, that'll speed things up. Like you can recognize that this x plus 1 squared is the sum of squares, which would be a squared plus 2ab plus b squared. But in case we're not very familiar with that and don't know that off the top of our head, well, we can still look at this and we can literally do what it says and expand it. We can turn this squared into the same binomial, so x plus 1 times x plus 1. X plus 1 times itself. And we have 2x plus 1, so that's x plus 1 squared. I'm going to put this minus x squared in another color because we're not going to do anything with it for a while. And now we have x plus 1 times x plus 1. Again, this is a part where y'all are going to have to help me what method y'all sort of use to multiply these. So I'm just going to do what I think is a quick method, and if y'all give me another method to use, I'll be more consistent and use that method. But we have x times x, which is x squared. This is called double distributing. And x times 1, which is plus 1x, which I'm just going to write as x. 1 times x. And then 1 times 1, which is 1. So it's pretty much every term times every term. My first term times the other two terms, my second term times the other two terms in the binomial. And again, still not really doing anything with this x squared, but I don't want to leave it behind. I don't want to forget it. And now we're just going to combine like terms, which, well, actually this is where we do something with the x squared because we have x squared minus x squared. We also have x plus x, so we're just going to, x squared minus x squared goes to 0, so that goes away. X plus x is 2x, and we have a plus 1 left. So we expanded that to get 2x plus 1. There's our first expansion, and this type of expansion will come up later in limits, and it's going to be a pretty important idea when we get towards the end of our, no, I'm not going to say the end, but when we start reaching the end of our first unit. Okay, our second expression, there are a couple ways to do this. So I said before, you have x plus 1 squared, you can recognize that's a sum of squares. Then you have x plus 2 cubed. There's an analogous thing for this, which would be like Pascal's triangle. Someone showed me that earlier today. I do not know how to do Pascal's triangle, but if you want to look it up and figure it out, you can. I'm going to actually do it the way we did it here. And we're just going to have to be kind of fast with it. But we have x plus 2 times x plus 2 times x plus 2, again, minus x cubed, just because I don't want to forget it. And for this, I'm going to do it piece by piece. So I'm going to focus on, let me choose a different color. I'm going to focus on these first two, and I'm going to multiply them out. So that would be x times x times 2, 2 times x, 2 times 2. So we have x squared plus 2x plus 2x plus 4. That's all times x plus 2. Don't forget my minus x cubed. This can simplify. I want you to be at a point where you can kind of do these binomials in your head.
Valencia, Mr. Gray, Ms.
And you can hear Dr. Hyder talking to us, calling people to his office. But we get x squared plus 4x plus 4 times x plus 2 minus x cubed. And now we're going to distribute again. And this time it's not just double distributing. I don't think there's a nice word for this, so I'm just going to call it distributing. But it's every term times every term. So, and I'll do it step by step actually. Let's choose green. Okay. So x squared times x and x squared times 2. So we get x cubed plus 2x squared. Not this color. Sure. And then we're going to do 4x times x and 4x times 2. So we get plus 4x squared plus 8x.
Mr. Gray, Ms.
Orange.
Valencia, may you please come down to the office?
4 times x, 4 times 2, plus 4x, plus 8. And then, of course, our minus x cubed. And now we've distributed everything. We have a ton of terms that we can combine, which I'm not going to go through the underlining and circling, but we have an x cubed term and a negative x cubed term. Those will go away. They'll go to 0. We have 6. I don't like the way that 6 looks. 6x squared plus 12x plus 8. And that's us expanding out a cubic expression. Okay. Hopefully that will help you when we get to expanding expressions, and if you have a chance to review it before your pretest. These are all things that, well, the expanding isn't on the pretest, but the other stuff is on the pretest.